So the radioactive isotope of phosphorus. Now, the radioactive isotope P is used in diagnosing of cancer. It's injected into the human body and it decays gives radiation. These radiation are detected by an appropriate device to create the image of the inside of the human body. So the aim of this exercise is to determine the dose of the radiation absorbed by tissue during 6 days. Phosphorus 32 is beta minus emitter and it disintegrates to give the isotope S. You have all the given, you have the period of the phosphorus, so pay attention here, and you have also how to convert. The disintegration of the phosphorus given in this relation determine A and Z. So part 1, in order to determine A and Z, so we do according to the conservation. This means according to Soddy's law, so according to the conservation of mass number A, we have A before is equals to A after, which means that 32 equals to A plus 0, which means that A equals to 32. We also have the conservation of Z, the charge number. This means we have 15 equal to Z minus 1. That means Z equals to 16. And هيك بنكون عرفنا ال A with Z قد إيه. Now prove that the energy liberated by the above disintegration is this much. Now in order to find the energy liberated, so this is 1.2, the energy liberated is given by delta mc square, and this is the energy liberated, so ما ننسى it's liberated by the decay of one phosphorus. So EL equal delta m times c square means it's m before minus m after and multiplied by c square. Now before we have the phosphorus, while after we have the sulfur and the electron. Okay, so it all multiplies by c square. هلا لما نيجي نحط numbers هنحطهم, we have the units in U. So first of all, we'll put the masses in U, in atomic mass unit. Okay, and then we'll convert. So هيطلع عنا here the answer. It's 31.96 minus 31.96393 plus 5.486 times 10 to the power negative 4. This is all for the masses, okay? And بس هو ده اليونت اللي لهم كلهم هن in U. So we multiply, so بنحولهم لميجا electron volt. We multiply by 93.1.5 mega electron volt over c square, and we don't forget times the c square here. So times c square. So we simplify, and then we get the answer. It's approximately equal 1.706 mega electron volt. So approximately this will be the answer. So ما ننسى هيدي the energy liberated by the decay of only one phosphorus. Now we continue the next question. Okay, so the sulfur is produced in the ground state. Pay attention to each word. The emitted antineutrino carries energy of this much, so the energy of the antineutrino, 1.31. The above disintegration is not accompanied by the emission of gamma rays. Why? So we know that the gamma rays هن بيجوا نتيجة ال de-excitation of the daughter nucleus, يعني بيكون excited and it will de-excite. Okay, so here بنطلع على given the sulfur nucleus is in ground state, and it's not excited. So why gamma rays are not emitted? Since in this case the daughter nucleus is not excited, it's not an excited level, إنما it is in the ground level, the ground state. Part 132, calculate the kinetic energy carried by the emitted electron and the sulfur are knowing that the sulfur and the phosphorus are considered at rest. Now we know in the energy liberated which is due to the decay of the phosphorus, it shows in which form? It shows in the form of kinetic energy for the daughter nucleus plus kinetic energy for the electron plus the energy of the antineutrino and minus the kinetic energy of the parent nucleus, which is the phosphorus. Now عم بقول لنا the phosphorus and the sulfur both are at rest، يعني هو اثنيناتهم صاروا zero. But we have E liberated, which is equals to طلعت معنا 1.706 mega electron volts. We have the energy of the antineutrino, it's 1.011 electron volt. Plus, the question is to find the kinetic energy of the electron, so سافيا نطلع. So implies the kinetic energy of the emitted electron is equals to, which is beta minus يعني, is equals to 0.6996 mega electron volt. So it's 1.7 minus 1.001. And this will be the kinetic energy of only one electron that's emitted. Now, part two. A patient is injected by a pharmaceutical product containing phosphorus 32. The initial activity of the phosphorus is A0 equal this much. Calculate in second minus 1 the radioactive constant. Now, in order to find the radioactive constant, we know that this is part 2.1. We know that lambda is equal to ln2 over the period, which means that we must have the period. إذا بنطلع لفوق كان معنا البيريد 14.3 days. So كان معنا إياها للبيريد. So it's ln2 over 14.3, but this is in days and the question is in second minus 1. So نحولها لhour 24 and then نحولها لسecond 3600, which means that lambda is approximately 5.61 times 10 to the power negative 7 second minus 1. Part 2.2. Deduce the number n0. So it's deduce. Deduce, this means from the parts before. N0 present in the pharmaceutical product at T0 equal to 0 second. We know that the activity A0 is equal to lambda multiplied by N0. The question is find this number. So N0 equal A0 over lambda. And pay attention, even if the radioactive constant the question wasn't in second minus 1, I cannot use it in day minus 1. حتى لو طلعناها بالday minus 1 قبل مضطرين نرجع نحولها in order to use it and find the number. So لكن here لأن A0 is in SI unit, which is VQ. And all over lambda. So we get as answer, it's N0 equal 2.424 times 10 to the power 12 nuclei of phosphorus. So initially كان عندي هالقد phosphorus. Now part 2.31. Determine the remaining number at t equals 6 days. Now, in order to find the remaining number, okay, so we have n equal n0 over 2 to the power n. Can mine n0 قال لي 6 days يعني I can find the number of period. So I can say that the number of period is given by t over big T, which is equals to 6 days over the 14.3 days, which is equals to 0.4195. This is the number of the period. So I can find a قد بقى عنا phosphors that were not disintegrated. So which means that n equal n0, it's equals to 2.424 over 2 to the power 0.4195, which means it's approximately we have remaining number 1.812 times 10 to the power 12 nuclei. يعني after 6 days بقى عنا هالقد النيوكلياي that were not disintegrated اللي هن خاصهم بالفوسفورس. So deduce the disintegrated number. Now in order to find the disintegrated number, so يعني ما نطلع ال N D. Okay, N disintegrated. قد تفكك. I have the initial number was this much. The remaining number was this much. So in order to find the number disintegrated, so N disintegrated is equal to N0 minus N, which means that we have N0 and we have N. So بيطلع عنا the answer is 6.12 times 10 power 11 nuclei. يعني هالقد عندي nuclei يتفككوا. اوكي and تحولوا لما تفككوا يعني تحولوا لسلفور. so كان ممكن يكون السؤال not the juice that disintegrated and disintegrate of phosphorus. It can be deduced the number of sulfur formed during the 6 days. Okay, it will be the same question. So part 2.33. Now we have to find the number of the emitted electron is this much. So during the 6 days. Why؟ نحن بنعرف إنه إذا بنلاحظ أول شيء إذا بنلاحظ هيدا العدد the number of electron that's emitted or that's produced إذا بنلاحظ هو ذاته العدد اللي طلع معي that's disintegrated. Okay, and we already know that the number disintegrated. How do you find the number disintegrated? So the number that is disintegrated is the same as number that is formed. قد ما تفكك عندي phosphorus طلع عندي بالمقابل electron. So this means I can say that ليه؟ لأنه بنلاحظ بالequation here for each one phosphorus عم يطلع معي one electron. So لكن here we can say that the number of disintegrated nuclei of phosphorus is equal to the number, so this is phosphorus, is equal to the number of electrons that were produced or that were emitted, since each one phosphorus is emitting only one electron. The decay of 1p produces one electron only.